Okay, so now that we have talked about energy, we can start talking about work. So, work is the transfer of energy. And this is going to be dependent on the force that's applied to the object and the displacement of the object. So, remember, displacement is how far it moves. So, mechanical work, which is what we're mainly going to focus on, is done on an object when the force displaces the object in the direction of, or um, in the direction of the force or a component of that force. So these are the two formulas we'll use. So work is force times displacement, or it's force times displacement times the cosine of the angle if your force is acting at an angle to the object. All right, so let's look at a couple examples here. So let's say you're going grocery shopping, right? And you push a cart with a constant force of 35 newtons forward for a displacement of 4.5 meters. How much work would you do on the cart? So again, your force is 35 newtons and your displacement is 4.5 meters. So again, work is force times displacement. So you're going to do 35 times 4.5, which would equal 157.5 joules. So joules is going to be our unit for energy. It's also going to be our unit for work. All right, so again, if we've got a force being applied at an angle, not all of that force is going to contribute to the work. So sometimes we have to use that other formula, which is work is force times displacement times the cosine of the angle of the force. All right, so in this example, we've got a sled going at a force of 50 newtons. And you're pulling it with a rope at a 37-degree angle. And how much work is done on the sled if you walked 0.5 kilometers? So remember that when we're talking displacement and force, we need to be using meters. So we get to do everybody's favorite thing and convert this value, right? So 0.5 kilometers is going to be equal to 500 meters. So then when we plug those numbers in, we'll have 50 times 500 times the cosine of 37. And that will equal to 19,965.89 joules. And we'll go to two decimal places like we typically do for these kind of problems. Okay, and so there's three different situations where there would be no work done. So obviously, if your force is equal to 0, that means your work would be 0 because, again, you're multiplying the two numbers. Same thing with displacement. And then if the force that's acting on the object is going to perpendicular to your displacement, that is another situation where you would not have any work being done. So if you're lifting a briefcase with a force of 19.6 newtons up, right, so let's draw a free body diagram. So we've got a force going this way, but your displacement is going east, right? So again, that's going to be perpendicular, so that automatically means your work would be 0, right? Because that means theta would have to be 90 degrees, right? All right, and then let's kind of apply this with what we've done with our force problems as well. So you have a cardboard box that has a mass of 53 kilograms. And it's getting pushed along a 12-meter long driveway. So that's our displacement. Our coefficient of friction, or mu, is 0.38. And it has an applied force of 210 newtons. Okay, so for our free body diagram, again, we've always got Fn and Fg. We're on a flat surface, so those will be equal to each other. We have our applied force of 210 newtons. And then going to the left, we're going to have our friction force. So we need to determine the work done by the guy delivering the box. So the work done by our applied force and also the work done by our friction force. So for the applied force, that one's going to be pretty straightforward. So that one would just be force times displacement. So our 210 Newton applied force times our displacement of 12 which would give us 2,520 joules. Then to find the work done by friction, we have to find our friction force. So remember, Ff equals mu Fn, but we don't have Fn, so we're going to have to find that by first finding our force due to gravity. So Fg is our mass times 9.8. So we'll do 53 times 9.8, which will give us 519.4 newtons. And then we know that Fg and Fn are equal. So now we can use this as our Fn. So we'll do 0.38 times that 519.4 to get that our friction force is 197.4. And then to find that work due to friction, we'll do the 197.4 times our displacement of 12, which is going to give us 2,368.8 joules. Now we're going to go ahead and make this one negative since that force is acting in the direction opposite of the motion of the object.